So let's look at a second equation from 2 points problem. And I'll look at this one just a little bit differently and actually build on some of what you have learned about using tables and how we write equations for tables. So once again, we're writing the equation for a line that passes through 2 points, and the 2 points we're given are 1, 3 and negative 2, 5. We are hoping to write an equation in the form y equals mx plus b. And remember, to use that form, we're going to have to find the slope m and also find the y-intercept b. Now, we could use the slope formula to find the slope between those 2 points, but I want to show you how you could make a quick little table and use a table to accomplish the same goal. So I'm going to make an xy table. And I'm just going to have 2 rows in my table, 1 row for each of my coordinate pairs. Now, when we usually make a table, we usually arrange it in a way so that the x's are going from smallest to biggest as you work down in the table. So if I look at my 2 coordinate pairs, it's my second coordinate pair that has the smaller x value, an x value of negative 2 compared to an x value of positive 1. That means I'm going to lead my table with that negative 2, 5 coordinate pair. So I'll put that into my table, negative 2 and 5. And then underneath it, I'll write my other coordinate pair of 1, 3. The reason for introducing a table is now we can use the strategies that we've used previously when we've been working in a table. So now we can find the slope by looking at the change in y and the change in x. So if I look at the table, I can see that my y is going from a y value of 5 to a y value of 3, and that is a change of negative 2. If I look at the corresponding change in x, moving from a negative 2 up to a positive 1, that's a change in x of positive 3. And now to find the slope m, I can just do the calculation, change in y divided by the change in x. And again, that's like rise over run if you were working on a graph. So our change in y is negative 2 over our change in x is positive 3. So we have a slope of 2/3. So once again, we're kind of halfway there to getting to our y equals mx plus b. We know that y equals negative 2/3 x plus some b value. We still need to find our y-intercept. And again, we could use a table to help us find the y-intercept. Now, you could use that strategy of substituting the x and y values of a coordinate pair and substituting those in place of x and y in the equation and then solving for b. That will certainly work here. But I just want to show you another strategy where we can use a table and build a more detailed table to help us find the y-intercept. So here's how we would go about doing that. Remember that the y-intercept, and again, that's the b value in the equation, that's the y value when x is equal to 0. If we look at the little table we built over here, an x value of 0 would be somewhere in between this negative 2 and negative 1. So if we can fill in some rows in between those two numbers, that could help us to find the y-intercept. Now, sometimes an x value of 0 might be somewhere above where your table rows are or somewhere below where your table rows are. So sometimes you might have to build a table backwards or build a table forwards to help you find the y-intercept. In this case, we're wanting to add more details to the table in between the rows that we have. So I'm going to make another xy table, a little bit bigger, and I'm going to make some rows. And I'm going to start with the coordinate pair we started with, which was negative 2, 5. And then what I'm going to do is I'm going to work my way down in the table, increasing my x values just by 1. So from negative 2, I'll go to negative 1 to 0 to 1. And I'm going to stop there at 1 because I've actually reached the x-coordinate of the coordinate pair that we already know in the bottom row of this table. So since I have an x value of 1 here and an x value of 1 here, I can go ahead and write the y value of 3 in my new table over here. And you can see now this new table actually has a row that will have the y-intercept. So So all I need to do is fill in these missing y values, and if I do that carefully by using the slope, I can figure out the y-intercept. So now we have to use the fact that our slope is negative 2/3. And what that slope, remember, tells us is that's how much the y is changing when the x goes up by 1. And we can see we designed our table so that the x was going up by 1 every time. So now what that means is our corresponding change in y is equivalent to our slope. So we're actually going up by negative 2/3. I guess I should say going down by negative 2/3 each time. So I'm going to take the 5, I'm going to subtract 2/3 and write my next y value, subtract 2/3 again, and write my next y value there. So 5 minus 2/3, well that is just, let's see here, that's 4 1/3. And then if I subtract 2/3 again, that's going to be 3 2/3. And then as a little check, I can see that if I do subtract 2/3 again, I do actually get to the 3. And I knew that 1/3 was a point on our line. So now, right here in this row in our table, we can see that the y value, 3 2/3, corresponds with an x value of 0. So that is our y-intercept, or our b. So now we can write our final equation. Y equals our slope, negative 2/3, times x, plus our y-intercept of 3 2/3.